All right, here's the question we're being asked to do. One thing I think would help us is, before we do this question, to go back to a question we've done in the past that will sort of ease us into this more difficult version of that same question. In the past, we were given this problem, and we were told to find the cosine of m based on the given information. Well, the cosine of m is the x-coordinate of the terminal point, so if we let xy be the terminal point of arc m, then the tangent can be expressed as x over y, and what we've, y over x. And what we've done here is create an equation out of the tangent of m, or what we know about it. But we also know that m terminates somewhere on the unit circle, and any point on the unit circle satisfies the equation x squared plus y squared equals 1. So you'll notice on the left side, I solved that equation for y. I could then plug that in for y in the unit circle equation. And after that, and we did this problem before, but after that, we just did algebra and solved for x. And because the cosine was greater than 0, notice the given information, we're able to determine that the cosine is positive 4/5. Anyways, this is not the problem that we're doing right now. But if you need to hit pause and familiarize yourself with this problem we did in the past, do that now. And I'll move on. Back to the problem that we want to solve. Before I go about the business of finding the cosine of m, there's something about the 3 bullets I'd like to point out. There seems to be some redundancy in this information right here. Let me see if you can follow me on this logic. M terminates between 0 and pi over 2, meaning it terminates in quadrant 1. If m terminates in quadrant 1, then the tangent is going to be a positive number, and therefore k is going to be a positive number. If k is a positive number, then this information here is really already kind of built into the second and third bullets. So the second and third bullets imply that k is going to turn out to be positive anyways. So I thought I would just temporarily ignore the bullet that reminded me that k is positive. Nonetheless, let's get on to the problem of finding the cosine of m. M is some arc, and it terminates at some point. If I let xy be that point, in other words, if I define xy to be the point where m terminates, I can make some equations out of x and y that will enable me to solve this problem. First of all, let's take the fact that the tangent of m equals k, some unknown number, that was given to us. The tangent is always the y-coordinate divided by the x-coordinate. And now I have one equation involving x and y. But also remember, m terminates on the unit circle, and any point on the unit circle satisfies this equation. So I now have 2 equations, both with x and y in them, that I could solve and get some information about what I ultimately want, which is the cosine of m. In fact, let's reflect on that for a moment. The problem is telling me to find the cosine of m as a function of k. The definition of the cosine of m is the x-coordinate of the terminal point. And so it's x I'm trying to find. So I thought what I would do with these 2 xy equations is solve the one on the left for y. Reason? If I solve that equation for y, I can substitute that into the other equation, thus giving me an equation that will allow me to solve for x, which is what I want to do after all. So I did some algebra here. I distributed the exponent. By the way, exponents don't typically distribute to parentheses, but they do when it's a product inside them or a multiplication. And I then factored out an x squared. I'll pause while you process that. The reason I factored out an x squared is because in order to solve for x, I could now divide both sides by 1 plus k squared. And then applying the radical property, I found two possibilities for x, a plus and a minus possibility. But remember, m terminates in quadrant 1. Therefore, the x-coordinate is positive. And since the x-coordinate is positive, the plus or minus symbol is going to turn into just a plus. So now, what have we done? Well, we have found x as a function of k, which is essentially what we want to do, because the cosine of m is x. But let me simplify this a little bit before we conclude this problem. First of all, while radicals typically don't distribute, they do distribute to a fraction. I can further simplify the numerator here because the square root of 1 is 1, of course. And beyond this, don't try to simplify the denominator because the denominator, that radical doesn't distribute to a sum of terms, so there's nothing that I can do down there. I could rationalize the denominator here, but typically when variables are involved, we don't bother to do that. So I've essentially simplified x as much as possible. But remember, xy was the terminal point of m, and therefore, by definition, x is the cosine of m. So having found x is the same as having found the cosine of m, which is precisely what this problem wanted me to do. And now I have found the cosine of m as a function of k. And that completes this problem.